Welcome to June 3rd's LeetCode challenge. Today's question is maximum area of a piece of cake after horizontal and vertical cuts. Given a rectangular cake with height h and width w, and two arrays of integers, horizontal cuts and vertical cuts, where horizontal cuts at index I is the distance from the top of the rectangular cake to the ith position of the horizontal cut, and similarly, the vertical cuts at index j is the distance from the left of the cake, rectangular cake, to the ith position of the vertical cut. Return the maximum area of the piece of cake after you cut at each horizontal and vertical position in the array, horizontal cuts and vertical cuts. Since the answer can be huge, return the modulo of this number here. And let's just copy that. We'll need it later. So an important thing to note is that these are the inputs. So they give us the height and the width of the cake, and they give us a bunch of ith position to cut the cake in horizontal right here. Boom, boom, boom. And they give us a bunch of numbers at the jth position to cut it vertically as well. So a couple of things to note is that at index 0, that's also a cut, and for horizontal and vertical as well. And the very last height of it is also a cut area. So the borders of the cake are considered a cut region. So they should be included, but they're not included in the horizontal cut given here. And another thing to note is that horizontal cuts and vertical cuts are not typically always given in order. So they could be out of order, so we need to sort that first. So the approach to the solution would be to basically sort the include the zero, the border cases, sort the horizontal cut array and the vertical cut array, and then find the largest difference between the cuts. So find basically the cut and the cut before it, whether it's the largest difference, and then we multiply those together and do the modulo of that with this number. Alright, let's solve that. Let's see, constraints here. Yeah, so let's sort this using Python. So the first thing we want to do is add our edge cases. So we want to say, first of all, I'm going to paste this down here. Horizontal cuts dot append. So you want to add 0, which is the edge case. For the very horizontal would be the top edge of the cake. You want to add the bottom of the cake as well, so which would be h. And then we want to do the same thing for the vertical component as well. Just copy and paste here. Vertical. Oh, what am I doing? Vertical cuts append, and then we want to append w here, and vertical. So now that we added basically our horizontal cuts border, now we want to do is we want to sort it. Horizontal cuts dot sort, and we want to sort the vertical cuts array as well. Cuts dot sort. Alright, now that we have our array with 0 included and the maximum, the edge cases of the cakes included, we sorted it. Now let's define maximum height and vertical components, which we're going to use to multiply together to get our answer with modulo. So we define a variable called, let's say, max height, max vertical equals 0, 0. Let's do that. Alright, let's do a for loop here for I in range. We're going to cycle through our, starting from 1 to the length of the horizontal cuts at index, in our array. We're going to what we're going to do is going to find our cut to be at the position we're at, horizontal cut at index I minus horizontal cut at I minus 1. And then if the cut is greater than the maximum height we have, then what we're going to do is make max height cut equal to the cut that we have that's greater. Excellent. So now we have that for the horizontal component. We're going to do the same thing for the vertical. So let's just use the notation here for j in range from 1 all the way to vertical cuts, length of vertical cuts I should say, vertical cuts. We're going to do a very similar technique. If cut is equal to, will be equal to vertical cuts at index j minus vertical cuts at index j minus 1. If cut is greater than maximum vertical cut, then maximum vertical cut will be reassigned to cut. Let's see, what else do we need? Now you want to return maximum height cut times maximum vertical cut modulo this number here. I think we need to change that to this. Alright, so we have this 0 appended, horizontal cut, this appended, width sorted, height, yeah, for I in range. Let's see, let's run the code. Of course, I spelled horizontal cuts. Oh my goodness, horizontal cuts. Alright, that seems to be working. Let's see if that works. Accepted. Awesome. So the time complexity of that would be O of n log n, because we are every time we go closer to a cut, we just minus it from the one before it, and we have to go through it n times for each element in the range. Right, so we're halving our and time complexity is constant time. So yeah, because we go through it no matter what, where we go through a constant time. I mean, space, I should say, it's constant space memory, because we are developing. Yeah. All right, that's a pretty fun one. All right, have a great day. Let's see the hints here actually. Sort the array. Yep. Compute the maximum difference between two consecutive elements of horizontal cut and vertical cuts. Wow, that's what we did. And the answer of these products of these maximum value horizontal cuts and vertical cuts. So yeah, that's what we did here. We sorted the array. We multiplied these two together and we found the difference, and then multiply them together. And that's it.